All right, guys. Today we're dividing polynomials. So right here we have a little bit of a review. Dividing polynomials by a monomial, we know how to do that already. All we have to do is split it up. Take your numerator polynomial and divide each term by the divisor. And then you just simplify. Sorry about that. Okay, so we split up our numerator, the dividend, put each term over our divisor, and simplify. 6 over 3 is 2. X to the fourth divided by x squared is x squared. 4 minus 2 is 2. 15 divided by 3, don't forget the sign, is 5. X cubed divided by x squared, that's just an x. 3 divided by 3 is 1. X squared divided by x squared is 1. 1 times 1 is 1. Anything divided by itself is 1. So you know how to do this already. We did this. Nothing new there. Same thing on this next one. Just split up each term in the numerator. Put it over our divisor. So whenever we're dividing polynomials, we need to first decide what thing is our divisor. Is it a monomial? If it's a monomial, just split it up. Is it a binomial? That's what we're getting to next. Is it some other polynomial? Well, then we'll talk about that too. For right now, we're just looking at a monomial because we have one term down here. There's no pluses, there's no minuses, it's just one term. So to do division by a monomial, all we do is split it up and simplify. And we did this before, so this is nothing new. And that's what we're left with. That's a 9a. I'm terrible at writing, but you all know that. There we go. Much prettier. Anyway, so that's how you divide a polynomial by a monomial. We did that. Now what happens if we have a binomial? Well, we know how to factor polynomials, so that's the first thing we could try. It is a lot easier if we can factor it. So I'm going to do the AC shortcut. We're only interested in the AC shortcut and factoring this if this is going to cancel. If it doesn't cancel, what's the point? So let's see. I need a negative 5 as a factor. And 10 times 1 is 10. You get a negative 7. Shoot. So if I use negative 5, is it going to work? What times 5 is 10? 2. What times negative 5? Negative 2. And yeah, that does work. So if it does factor and it does cancel, then we'd have to use this thing. So it helps us figure out what our factors here need to be. So negative 5 over 1, negative 2 over 1 doesn't do anything. No simplifying there, so just middle term has a w in it. 1w minus 5, 1w minus 2 over w minus 5. Notice we're just dividing here. We're not solving an equation. This is just dividing polynomials. There's not going to be x equals or w equals. There's no equal sign here. We're just simplifying. If we divide those two, we get w minus 2. That's it. Okay, so sometimes it can factor. Not all the time, but sometimes. And if it can factor, well, just do it. It's easier. This is just represented a different way. We're dividing by h minus 2 here, so this is our divisor. This is my numerator. AC will be negative 8. B is negative 7. And we know we need a negative 2. But since our A is 4, it might look a little different. So let's see. Well, we know the factors of negative 8 that add up to negative 7, negative 8, and 1. Oh, sorry, not the negative there. Negative 8 and 1. There we go. Put your divisors or your factors over A. And simplify. There's that negative 2. And so it doesn't simplify. So our factors for our numerator are 1, and our variable here is h. So h minus 2 right here. And then 4h plus the 1. So that's my numerator. My denominator is still h minus 2. I'm just grouping it because, well, we need to remember that this is one thing. That is one number, one single divisor. So we can't divide a piece of it. Those cancel, and we're left with 4h plus 1. Not too terrible, right? Now, I know what you're thinking. Not all polynomials are factorable. You're right, they're not. Not all polynomials can be factored by the AC shortcuts. So, if you can factor, great. But what if you cannot? Here's where we're getting to long division. We'll start long division, and then we'll go to synthetic division. You know how to do long division. You did it in my wife's class, 6th grade. Now, some of you may have learned some little cutesy shortcuts to remember the steps. Daddy, mommy, sister, brother, or dragons mean serious business, you know, whatever. Don't care. As long as you remember the steps, it doesn't matter how you remember the steps. So let's rewrite this. Let's rewrite our division statement with the long division symbol. So our divisor goes out front. That's plus 8. You can put it in parentheses or not, whatever. And that goes into our dividend, x squared plus 3x minus 43. Yeah, let me get this out of the way for a minute. This is the step of things we do. We divide, then we multiply, subtract, and bring down. We'll see what that looks like in just a second. I'll put it up here. Dragons mean serious business. Daddy, mommy, sister, brother, however you remember it, don't care. I would highly advise, if you're not very fluent, that you do scratch work every single step of the way. What we do is we divide our first terms of each. Okay? So whatever term we're looking at over here, divide by the first term in here. So x squared divided by x. Well, that's easy enough. That's x, right? So that's what's going to go in here. That's our quotient. That's the division. Then we multiply. What do we multiply? Our quotient times our divisor. That's going to be x squared plus 8x. That's what we're going to subtract. We're going to put it right underneath here. And we're going to subtract it. Now, you could distribute that negative if you need to, or you can just read it in your head. Whatever you got to do, you got to do. X squared minus x squared is nothing. I'm not going to write it. 3x minus 8x is negative 5x. We did the subtraction. Now we need to bring down. Negative 43. Now again, we're going to do some scratch work. We're going to divide this, our first term, by our first term here, x. So negative 5x over x is just negative 5. Again, that's our quotient. Take our quotient, multiply it times our divisor. Distributive property. And that's what we're going to write right here. This is what we're subtracting. Negative 5x minus negative 5x, nothing. Negative 43 minus a negative 40 is a negative 3. Use a calculator if you need to. Now, we get to the interesting part. If we try and divide this by x, there's no x's here, right? So this is our remainder. So do you remember what we do with remainders? Let's go take a look at a numerical example. Let's do 5 divided by 3. Okay. Or let's do 51. That doesn't have a remainder. Skip. 52, because that has a remainder. So 3 goes into 5. So dragons mean serious business again. 5 divided by 3, that goes in 1 time. 1 times 3 is 3. Subtract. Bring down. Divide. 22 divided by 3, that goes 7 times. 7 times 3 is 21. Subtract. And there's nothing to bring down. So you could do your decimal thing and keep going, but what if we just want to leave it as a remainder? A remainder of 1. What do we do with that? Well, this is 17 and 1 over our divisor, 17 and 1/3. 1 second. And that's exactly what we're going to do here. We take our remainder, whatever we have left over, and put it over our divisor. So let's go back. This is our remainder. We put it over our divisor. It's negative, so you could either do the plus and then negative 3 over x plus 8. That's fine. I like to do personally just whatever sign it is. Negative 3. It's negative 3 over x plus 8. And that would be our answer. That's it. It's the same exact thing you did in 6th grade. Just instead of numbers, you got some variables in there. So now, long division will always work. Okay? But there is a shortcut. If you're dividing by a binomial, which is pretty much all we're going to do, you can use what's called synthetic division. For synthetic division, you must be dividing by a binomial, and you must figure out what makes your binomial divisor equal to 0. So, if I'm looking at it, this is x plus 8. What makes x plus 8 equal to 0? Well, negative 8, of course. So we're going to start by putting that in the box. We're going to go box. We're going to write down our coefficients of our dividend. It's a coefficient here, 1, 3, negative 43. Go ahead and skip some space. Yeah, I did this a few weeks back because I got confused on classes and thought we already did this, but yeah, we didn't whenever we're doing multiplicities. So now you can use this for multiplicities whenever you learn it. So here is the process for synthetic division. You write out your whatever makes your divisor 0, separate that, write down your coefficients of your dividends. The first step is always bring down the first number here, bring it down. Then we multiply the number in the box times whatever's down here. Then we're going to combine these two. 3 and -8, that makes a -5. Multiply, combine. And this last number over here is our remainder. To write out our new polynomial, we take our dividend and reduce the power by 1. It was x squared, now we're going to go with x. That's 1x minus 5. And our remainder is -3, so minus 3 over x plus 8. And we did get the exact same thing. Now, long division always works. Always. If you don't have a binomial as your divisor, you're going to go with long division. Now, if you can factor your divisor into a bunch of binomials, then you can do each binomial separately and keep reducing the coefficients. But for the most part, for this class, we're just going to stick with binomials. I think I'll show you a trinomial, maybe, but I don't think we're going to. Yeah, I don't think I'm going to touch on that. So all the ones we can do would be able to do with synthetic division if you want. So let's take a look at this one. I much prefer synthetic division, but if you prefer long division, that is perfectly fine. I'm going to do synthetic division on this one. First step, what makes my divisor 0? Well, it's n-7, so positive 7. Write down my coefficients. 2, -16, 19. And we must have our polynomial in standard form, and we cannot skip any powers. We'll get to one that might trick you in a second. First step, bring down first number here. Multiply, combine. Multiply, that's my remainder here, combine. So now we're going to write it out. It was a squared, so now it's going to be to the first power. 2n minus 2, positive 15, so plus 15 over, my divisor was n-7. That's it. This is easy as that. Let's check out the next one. Oh no, it's a cubic. It doesn't make a difference at all. Let's see what the next one is. I'll do this one by synthetic division. I'll do this one by non-division. So just in case you want to do a long division, it is much longer, but we can do it. Rewrite it with the long division symbol. And here, technically, you're supposed to use a parenthesis, but you can use a straight line. I don't care. Write out your dividend. Since this is a binomial, you can use synthetic division if you so choose. If you choose to use long division, well, that's fine. So first step, divide. Y cubed over y, that's y squared. Multiply. Distribute. That's what's going to be subtracted. And we are subtracting, so watch those signs. 5 minus -2 is positive 7y squared. Bring down. And we're going to divide first terms. 7y squared divided by y, that's just 7y. Now, it's perfectly possible to have a number over here in our divisor. Well, I haven't gotten there yet, but it's perfectly possible. 7y, that's our quotient. Positive, so put a plus. Multiply it out. If you're doing long division, please take the time to do the scratch work on the side. We get 7y squared minus 14y, and that's what we need to subtract. If I do subtract that, I get nothing there. That's going to be a plus 14, so that's a positive 7y. Divide that. Oh, bring down, sorry. Divide 7y by y, we get 7. 7 times y minus 2. Yes, long division does get long, but it always works. That's what we're subtracting. Don't forget to actually write your quotient up here. 7. And our remainder is, that's positive 16. 2 minus a negative 14. So plus 16 over our divisor. Now, perfectly fine if you do long division or synthetic division here. That's another example of long division. I'm just going to go synthetic from now on. So let's do it. Next problem. Now this one, they're trying to trick you here. So you got to pay close attention. First step, what makes our divisor 0? Negative 5. Could very well be a fraction here, so don't let that fool you. Second step, write down all of your coefficients. 1, look at it, look at it. How many k-squareds do I have? I have 0 k-squareds. There's nothing here for k-squared, so you got to write the 0. You have to write down all of your coefficients, or you're done for. That's it. Finito. Then we have the negative 17, the positive 32. So always, always, always make sure you write down every single coefficient, even if it's a 0. Bring down that 1, multiply, combine, multiply, combine, multiply, combine, and that's how to make it. So reduce the power by 1. It was cubic, now it's going to be the second power. So 1 k squared minus 5k plus 8 minus 8 over k plus 5. Next. Was that it? Okay, one more. Definitely doing synthetic division on this one because this would be quite lengthy with long division. So first step, what makes our divisor equal to 0? 8. I'll go inside the box. Write down my coefficients without skipping any. 8, negative 64, 0, there's no x squareds here. 3, negative 28. Let's blow my straight lines. All right, here we go. Bring down the 8. Multiply. Combine. Multiply. Combine. Multiply. Combine. Multiply. Combine. That's our remainder. So if you're if you know your multiplication fast, it's a lot faster. If you don't, then just take your calculator and push the buttons and just take 10 times as long. It's fine. It was a 4th degree, now it's going on the 3rd degree. 8x cubed, no x squareds, no x's, plus 3. Remainder of 4 over my divisor of x minus 8. That, my friends, is long division and synthetic division for polynomials. Again, synthetic division will work for any binomial. You just have to put whatever makes that binomial 0 in the box here. Long division always works. Take the remainder, put it over your divisor. That's it. That's all you have to remember. That's it for today. See ya.